So one of the first questions I wanted to ask is any innovation or any new product development or what we call R&D or design and development, however you want to characterize it. I mean, they do have subtle differences, but however you want to characterize it. From your perspective, what would constitute a good product? What would you call as a good product, please?
Yeah, so first of all, thank you for having me here. So, like you said, all the thermodynamic principles, I think, which are covered in the first four series, even though they are very informative, to have that a tangible benefit to the user, those must be delivered in a certain context. That's what we say as a product or a service, which one offers to the user by interpreting the basic principles of thermodynamics.
So,
now, whenever we are saying that the thermodynamic principles are as a lead into the new product, so whenever I say good product, the first of all, it should meet the user need. So what it has been designed for, that should do its job perfectly. And then it should have a repetitive, consistent behavior.
right.
Yeah, so that behavior has to be the consistent. And obviously, being we are in a competitive world, it has to offer value for you. Then we can say that is a really good plan.
Right. I actually like the way you put it. Basically, it doesn't necessarily just have to deliver the results, but it has to deliver the results consistently over its entire lifetime.
Yeah.
Okay.
Yeah.
So that's a very interesting way to put it. What may work on the lab scale, when you try to scale it up to an application scale, the things may be different.
Things are mostly different, because whatever we do in the lab, there we prove a basic principle of thermodynamics of basic engineering. Whenever we want to take that particular principle to actual field, the environmental condition vastly differs. So in which this particular phenomena, now then the entire ecosystem comes into the play. So whenever you are taking, suppose, a lab-based any prototype, we are developing the lab-based prototype here, and whenever we are taking to the actual field, the environmental conditions are vastly different, and that's what the most challenging part here. And that's what I think gives us as an engineers a challenge and as well as the pleasure to solve those problems.
Yes, and it's interesting actually, because what works in a very specified set of criteria may not always be applicable in real world scenario.
Yeah.
But this also, I think, translates to most of the products today. I would say even we are a little bit past that, but most of the products since about a decade have been interdisciplinary. You know, they are no longer siloed in such a way.
They're almost side.
Yeah.
So if you take even any thermodynamics product today, it will have a basic strength of material, thermodynamics there into the plug, the great manufacturing in nowadays if you see, all the manufacturing advancements will be in the play, and at the same time it will be aided by a huge amount of electronic side, instrumentation and and when we combine all this field together, then that's what I think we can say that as a good product which is delivering the value in today's world.
Yeah, absolutely.
Yeah.
Because even I understand that if we are looking at it from product perspective, no product that we interact on a daily basis is any more siloed. Okay, even if you look at an automobile, it will have an overlay of everything from basic combustion all the way to AI.
Yeah.
So all of that needs to be taken into account into product development. Okay.